On behalf of the Indian Academy of Sciences, I have great pleasure in welcoming you all to the 28th mid-year meeting of the Academy.
Today's talk will be on understanding the effects of two competing forcings, climate forcings. One is the greenhouse gases, which is trying to increase the global mean temperatures of the planet, and whereas the other one is the increased emissions due to human activities, anthropogenic aerosols in the form of sulfates and black carbon, which are trying to reduce the solar insolation. And these two forcings apparently have affected the behavior of the South Asian monsoon in the last few decades, which I will be presenting. This is a part of my work done at our Center for Climate Change Research at IITM Pune. It's a teamwork. I'll be presenting the results from some of our experiments. Basically, this is to give a quick summary of this South Asian monsoon. We have, this is the Indian Peninsula, the Tibetan Plateau, the Indian Ocean. Basically, the monsoon, the land sea thermal contrast sets up this circulation which picks up the moisture from the Indian Ocean and is mainly responsible for the rainfall that sustains the socio-economic activities in India. But once this rainfall occurs, there is a release of latent heat due to condensation of water vapor, which in turn feeds the circulation. So this feedback between the circulation and latent heat release maintains the monsoon. And of course, there are year-to-year variations in the total rainfall received over the subcontinent, which is influenced both by the internal dynamics of the monsoon system and external drivers like ENSO. So when we look at this is from the IITM, we have reconstructed the rainfall going back from 1871, the well-known Parthasarathi time series. What we can see is when you look at the more than 130 years of data, in the second half of this period, the number of droughts have significantly increased. And there is a kind of decreasing trend in the seasonal monsoon rains. All over on a scale of the whole country, the rainfall has decreased by about 6 to 7%. And many of these events, we know that their droughts are associated with El Nino in the Pacific Ocean, which is associated with anomalous warming of the sea surface temperatures, but you also see many years which are not associated with ENSOs. So why is this long-term trend happening? That is the main question. Sorry. The other important signal is there has been a decrease in the seasonal monsoon rains. You can see it spatial, you can see it both the Indo-Gangetic plains and also over the west coast of India. And some pockets, of course, you see there is an anomalous, there's an increasing trend. And there was a famous paper by Goswami et al. In Science where they reported that the occurrence of low and moderate rains during the monsoon season, that frequency count has declined significantly, whereas the heavy events, more than 100 or 150 millimeters per day, those type of daily counts have increased. This is over central India. So this contrasting behavior, decreasing trend in the seasonal rains and increase in the frequency of heavy rainfall events, it has significant hydroclimatic impacts. And so the question is, why is this happening? And this is, so when we look at circulation in terms of back trajectories or wind patterns, we see that there is a decline in the flow from the Indian Ocean and Arabian Sea. The cross-equatorial winds have significantly weakened. And so the decrease in the monsoon rains is linked because of the weakening of the large-scale monsoon circulation. And and this we have seen from the 1950s we are seeing. So is this a climate problem? This is a famous carbon dioxide measurement from Mauna Loa. It has steadily increased Now it has crossed even 400 ppm, and we know that from the last several IPCC reports, the increase in the global mean temperature is associated with this increase in these attributable due to the increase in the carbon dioxide. And And when we look at the observed temperature pattern, this is for the period 1901 to 2012, the planet has warmed by about 0.9 degrees, and the warming is not uniform. Much of the warming, you can see this is an important point, warming is dominated mostly in the extratropical regions, whereas the rate of temperature increase is much lower in the equatorial latitudes. So with the IPCC reports, we know that the increase both in the global mean temperatures and even on continental scale, the experiments were done by the IPCC using models with and without the anthropogenic forcing. What they concluded was you can explain this increasing trend in the temperatures only when you include the effects of anthropogenic forcings like the GHG gases, greenhouse gases, without which you cannot really explain the observed warming trend. So they concluded that the warming of the climate system is unequivocal, and so one of the consequences of the temperature increase is the rise in the water vapor. This is known as the water vapor feedback. This follows what is known as the well-known Clausius-Clapeyron equation. For every degree of temperature increase, the water vapor increases by about 6 to 10%. So due to this increase in the water vapor, most of the climate models that participate in the IPCC, what are known as the CMIP models, this is from the latest IPCC report, the future projected rainfall is going to increase. This is what is the projection because of the increased humidity in a warming environment. This is one of the extreme scenarios, RCP 8.5. But how do we understand in terms of what has happened in the last 50 years where the warming has been significant? Because the increase in the GHG have produced a radiative forcing of about 3 watts per meter squared. So we expect the global mean higher temperatures to be much higher than what we really see. So why is this? Are GHG only the forcing agents? Are now, this is following Indo-X. There was a big program in the 1990s led by Professor Ramanathan. They looked at other emissions, anthropogenic emissions like sulfate and black carbon, and these are due to anthropogenic activities. These are basically cutting down the solar radiation reaching the surface through absorption mainly by aerosols like the black carbon, and reflecting type of aerosols like the sulfate, which mostly dominate in the extratropics. So these now in the literature it is known as the atmospheric brown clouds. So they have a hemispheric as well as regional variations, unlike the GHGs, which are more well-mixed gases, and the lifetimes are smaller. And because of that short lifetimes and regional nature of the distribution, they can really perturb the land-sea contrast, and they can thereby influence the climate system. And observations have shown that the decrease in the solar radiation by the anthropogenic, by the ABCs or the atmospheric brown cloud is something like 15 watts per meter squared from the period 1970 to 2005 based on the radiation measurement data. And we also know that the maximum temperatures, the daytime temperatures over the Indian region, they have not increased as much as it should have if it had only greenhouse gases. So there is some kind of a competing influence that is trying to offset the effect of the global warming due to the atmospheric brown clouds or the aerosols in terms of the temperature response. Subsequent studies by, again, Ramanathan's group, they argued that the aerosols, they affect not only the temperature, they also affect the precipitation patterns. They argued that the decreasing trend in the monsoon precipitation over India is due to the weakening of the sea surface temperature gradient, north-south gradient in the Indian Ocean, and they also apparently influence precipitation over other areas like the Sahelian drought, which has been going on for several years, and as well as in the East Asian monsoon region. So I think initially there was a lot of discussion how there was a lot of uncertainties in the impact of aerosols on the monsoon, and there were some studies which even argued that they can lead to enhancement of monsoon. But over a period of time, there is a kind of emerging consensus that anthropogenic aerosols like the sulfates and black carbon have contributed to the overall decreasing trend. Several studies have discussed various mechanisms. For example, Bolasina et al. Wrote a science paper arguing that it is basically the northern hemispheric aerosols over the Europe and America. These are scattering type of aerosols. They have introduced an energy imbalance and have weakened the monsoon circulation. And there are also studies where more carbonaceous type of aerosols are like the black carbon. They absorb the solar radiation in the boundary layer and they can stabilize the atmosphere and weaken. And there are also evidences of aerosol counts disrupting the organization of convection. So these are all the studies. Now I'll just discuss one important paper by Bolasina where they conducted experiments with the GFDL model, one of the famous centers climate modeling groups in the world, where they argued that the declining trend in the rainfall over North India was because of the anthropogenic aerosols and it cannot be explained by greenhouse gas effects. So only when you introduce anthropogenic aerosols, both the direct and the indirect effects, you get this precipitation reduction. But one of the problems with this experiment was that the precipitation due to the aerosol was not just over India, but entire Asia. It was precipitation, brought down the precipitation. But when you look at the observed precipitation trends, you see in fact, over eastern parts of Asia, in fact, there is an increased precipitation. And also the model had differences over the west coast of India. The patterns were different. And also they did not address the issue of extremes, daily precipitation extreme changes. So we wrote a paper. This is we and our colleagues at IITM, and we worked, this was with the French group at IPSL. These are our co-authors. We wanted to understand, decipher the desiccation trend of the South Asian monsoon hydroclimate in a warming world. And this was later on reported in the Nature News and Views by Deepthi Singh as a tug of war, because there are two competing forcing climate forces. One is the GHG and the aerosols. There are also other effects due to the land use change, which I will not be touching in my paper, because land use can also try to increase the planetary albedo. For example, when you remove the forest cover and replace it with cropland on a large scale over the South Asian region and Southeast Asia region, which has happened in the 19th and 20th centuries, they can again weaken the monsoon circulation. So what we did in our experiment was to take a global model because we wanted to resolve the rainfall changes and also the regional forcing as well as the topographic features. We wanted to capture them. We wanted to go for a very high resolution setup. So it is a global model with a kind of a variable resolution. So we have very high resolution where the grid size is less than 35 kilometers over South and South Asia, and also it extends and over parts of West Asia. But when you go away from the region of interest, the resolution gets coarser. And so we did 5 sets of experiments, climate change runs. One is known as the historical run, going from 1886 to 2005, where we included both the natural forcings like the volcanoes, because they throw up a lot of sulfate aerosols which go to the stratosphere and they can stay there for a long time, and also anthropogenic aerosols like the sulfate and the black carbon. And we also have land cover changes and greenhouse gases for this period. And this model, we have used only the atmospheric model, because whereas we use for the boundary conditions, we use the sea surface temperatures from the corresponding low resolution coupled model run. And we have a second experiment known as the natural experiment, which has only natural forcings like the volcanoes and the irradiance changes at the top of the atmosphere, and a future projection. This is a kind of moderate scenario where the radiative forcing at the top of the atmosphere is 4.5 watts per meter squared by end of this century. And we also had 2 runs with only GHG forcing varying for the second half of the 20th century, whereas the other forcing like due to aerosols and land use were kept to pre-industrial values. And the last run, the aerosol only run, where only the aerosols are varying during the second half of the 20th century, and the GHGs have been set to the pre-industrial values. And so this is a picture. The black line shows the mean rainfall, seasonal rainfall averaged over India. You can see that after the post-50s, the decreasing trend can be seen. And the historical simulation is the brown line, and that is continuing into the RCP 4.5. A very pronounced decrease can be seen. It is much more, the model exaggerates the drying trend, whereas the natural run doesn't show the drying. It shows some decadal, intraannual and decadal type variations, but you don't see a decreasing trend. And the advantage of having this high resolution is getting the mean values at around 8 millimeters per day, similar to the observations. But if you use coarse resolution model, your mean is very much underestimated. And this is the mean from the CMIP5 models. We have about some 30 models or so. The multi-model mean is very much underestimated, and there's a lot of spread. The coarser resolution coupled models, in fact, don't show this decreasing trend. In fact, they show a slight increase, and the mean values are much lower. So clearly there are value additions because of the use of high resolution. So you see a decreasing trend in the rainfall in the simulation. Another important point is the count of heavy rain events over central India. That has increased, and it is projected to increase. I'll just take 2 minutes. So what we are finding is basically the decreasing trend in the rainfall is associated with the weakening of the monsoon circulation. We see some increased precipitation over the oceanic region associated with warm sea surface temperatures. So when you look at the sea surface temperature boundary forcing in the aerosol run, we get an anomalous cooling. I've just shown over the Indian region, whereas in the greenhouse gas warming experiment, there's a significant increase in the temperatures and also in the historical run. This is the spatial pattern. This is the historical natural run, the mean rainfall and the winds. You can see if you use only greenhouse gases, we see an intensification of the monsoon circulation and increased rains over the Indo-Gangetic plain and west coast of India. Whereas in the aerosol run, there is a decrease in the precipitation. And there is some increase over the Himalayan foothills. This is very similar to a break type of pattern. When we have breaks in the monsoon rainfall, the monsoon trough shifts to the foothills. There is more rainfall there. So to understand the physical mechanism of the aerosol influence, this is the aerosol optical depth, a measure of how much extinction in the solar radiation happens in the visible wavelengths. And this is the radiative forcing at the top of the atmosphere due to the aerosol. Basically negative values, this blue color indicates that it is going to lead to a decrease in the temperature. And at the surface, it's much more pronounced, radiative forcing over China and India, suggesting that there's a lot of atmospheric absorption due to this. So how does the aerosol influence the monsoon weakening? Basically, when you are trying to put a negative radiative forcing, it cools the entire troposphere, and this is the difference between the historical and the natural for this full period. Because of the tropospheric cooling, the dynamical adjustment is such that the winds try to produce a very strong westerly winds, and this is the cold subsidence that happens over the Indian region. So the weakening of the monsoon is not just very local scale, it is happening on a scale of the Eurasian continent, where when you subject it to a cooling, the cold anomalies from the extratropics, they descend and subside, they produce sinking motion over India and kill the monsoon precipitation. So this is very similar to the monsoon breaks. A typical example, during 2002, we had this big drought, a kind of very strong break during July, and typically even observations of our Indian meteorologists have long back, they have mentioned that they have reported that during breaks, these mid-latitude westerlies, they kind of descend into the Indian region. And another consequence of the climate change experiment is that when you increase the temperature in the greenhouse gas experiment, only the water vapor increases due to the Clausius-Clapeyron equation, but not so in the aerosol run. So an immediate consequence is that its impact on the extreme precipitation events. So in the historical run and the greenhouse gas run, when we look at the heavy rain event count, more than 10 centimeters per day, you get a very significant increase at the cost of the decreasing rains. So in summary, this is a quick summary. For the historical experiments, what we find is that the moderate and low rains have declined when you have the aerosol forcing, whereas the heavy rains are increasing. But if you have only greenhouse gases, both the moderate and the heavy rains are going to increase because of more water vapor. And this increase in the very heavy events is because in the historical run, in the presence of aerosol, is because you have a weak monsoon circulation, a weak vertical shear, but lot of humidity because of the presence of GHG, so it can promote this localized heavy rainfall. So in summary, what we have shown from this model is the recent monsoon decline is likely influenced by anthropogenic aerosols with significant contribution from land use and land cover change, as well as the Indian Ocean warming trend. And we think that the anthropogenic aerosols are basically producing a large-scale cooling over the northern hemisphere and continental Eurasia, and this dynamical response to the energy imbalance weakens the monsoon via mid-latitude circulation anomalies. They are very much reminiscent of break monsoon conditions. We note a robust increase in the heavy rainfall occurrences. We think that because the monsoon has a very strong internal variability, especially the Indian monsoon rainfall, we need to have multiple realizations. But these were being high resolution experiments, they were computationally very, very expensive. And also we had an atmospheric only model. We need to go for a high resolution coupled model. So, and I just want to conclude this, and I want to say that we have developed the first Earth system model from India that will be contributing to the next IPCC assessment. Thank you, sir.
Intensification, the intense events you talked about, is there a simple reason why, I mean, can you say more about why weak shear or aerosol should cause that?
See, when you have for organized convection, for individual cloud systems to organize, one of the quantities is a good vertical shear. So in the monsoon environment, when you have the low level westerlies and the upper level easterlies, they allow the organization of the convection. And when the shear is very weak, all this overshooting type of convection can happen on a local scale, very much similar to the thunderstorms. So those heavy ones are related. So when the monsoon weakens, the shear weakens, but you have a lot of humidity in the atmosphere. So these localized events can go.
Even if it rains every day, every 65 days, heavy rain, more than 100 millimeters, you can have only 365 events. You have predicted some 1500 events per year.
So what we do is we take over that entire box, we count it at each grid box, whether it is exceeding, and we do it day by day. So 122 days, and since it's a 35 kilometer, the number of boxes are more for that entire. So it's a total count of events.
Sir, in spite of these reasons, the waters of Bay of Bengal is always about 1 degree higher than compared to the Arabian Sea and or Indian Ocean.
Correct. Yeah, Arabian Sea SSTs are cooler because there's a lot of evaporation, there's upwelling. When the monsoon winds, during summer monsoon time, there's a lot of upwelling which brings cold water from the lower layers off the coast of Somalia and Arabia, which keeps the water cooler. So the sea surface temperature in the Arabian Sea is cooler compared to the Bay of Bengal.
One last question.
Is there any relationship between the aerosols and the CFCs which created the hole in the ozone layer?
Yeah, CFCs are basically there. Some studies have shown that this was the work of. It's also a kind of greenhouse gas forcing. It can basically destroy the.
Do aerosols also destroy the?
Now there are some studies discussing about that. The aerosols can also potentially destroy because during summer monsoon time you have this organized convection. So studies are now reporting that this deep convection can take pollutants from the lower levels to the upper level, to the UTLS region in the stratosphere, where they can interact with, where they can contribute to.
Can be some aerosols to counteract the effect of the greenhouse gas increase?
Yeah, some people are trying about this geoengineering. That's still a kind of controversial issue. What are its other impacts, we don't know.
Thank you, Raghavan.
Thank you, sir.